Hey everybody, my name's Mike Miller. I'm the General Manager of AI Devices here at AWS, and I'm here today to talk to you about DeepRacer. DeepRacer is the fastest way to get rolling with machine learning through a cloud-based 3D racing simulator and a 1/18th scale physical car that you teach to drive itself autonomously around a track. DeepRacer is great for developers of all skill levels to get hands-on with machine learning in a fun way. And in fact, over 700 AWS customers have used DeepRacer to excite and engage their developers to learn DeepRacer. One of the things that we're doing to make DeepRacer even more accessible is through these arcade pods. In these pods, even somebody with no machine learning or software coding experience can get hands-on, learn about the specific machine learning technique to teach cars to drive around a track themselves. Let's take a look. Now we're in the arcade pod, so let's get started to race. The first thing you see is a prompt, whether you're new to reinforcement learning and machine learning, or whether you want to skip straight to the racing. What's great about the DeepRacer arcade pod is we've got a series of screens that teach you all about machine learning and reinforcement learning, which is the technique that's used in this case to teach DeepRacer to drive around a track by itself. Reinforcement learning is much like the way you teach a dog how to do tricks. You give them a reward when they do something correct. So as you can see on the screen here, we're going to give our car a reward if it stays along the center line. And as the car iterates, so the machine learning and the program runs it over and over again through many iterations, and as you can see on the graph on the bottom, the car learns how to maximize its reward. And in this case, maximizing your reward means driving along the center line. So once you finish that, we prompt you to get started with racing. So let's go. First, I pick a car. In this case, I'm going to pick the AWS DeepRacer model. It shows you my pedals and my steering, and then I'm going to get started. So here I'm going to probably keep the accelerator mashed down, and I'm going to try to cut corners so I can speed up along the track. Now, you're basically trying to get your fastest lap time here in 1 minute. So however many laps you can do. Now, you get penalized if you go off the track as well. So if all 4 of your tires go off the track, you get a 3-second penalty. All right, so my 1 minute of racing is up. You can see here on the screen that we've explained the characteristics of my driving style. And now what'll happen is it'll match the characteristics of my driving with another pre-trained model, and I'll have the opportunity to race against them. And the best way to think about this is like my doppelganger. So here I'm pitted against Heather, my doppelganger, who also was cutting corners and mashing the accelerator down. You just have to do 1 lap, and all I have to do is beat Heather, so this should be a piece of cake. There we go. So my lap time showing on the screen. I went ahead and beat Heather, luckily, in my lap race. And then we can submit our results to the leaderboard. And you can participate in the DeepRacer season in 2022. And the best way to do that is to visit deepracer.com to get started, or to visit one of our global AWS summits where you too can have a seat in the arcade pod and get your hands on machine learning.
Hi, I'm Tatiana Cooke, Principal Product Manager on the AWS Outposts team, and I'll be joined today by Atif Qureshi, founder of Vistry AI, and Josh Cohen, Senior Solution Architect, to talk about how Outpost technology can help our customers optimize operations and brew the perfect cup of coffee. AWS Outposts is a service that brings hybrid infrastructure to customer sites to help customers who need lower latency, fast response times, or local data processing for applications that need to remain on their premises or run out of a colo facility nearby them. We've helped customers in manufacturing, healthcare, and gaming with our existing Outpost 42U rack form factor. Now, for those of you who don't measure everything in rack units, that's about the size of a refrigerator. So it's a little bit big for some customers operating at edge sites like a cell site or a retail location. What we're introducing at re:Invent today are Outpost servers. These 1 and 2 rack unit high servers are designed to run in smaller sites so that customers can launch the same EC2 instances and use VPC networking on premises. The benefit of Outpost servers is that customers can design and deploy edge applications using the same AWS APIs and regional tools they're familiar with from cloud workloads. Now, I'll hand it over to Atif, who will talk about how, combined with Outpost servers, the Discern platform can help customers improve operations in retail and hospitality.
So today what we're going to show you is a glimpse into the kitchen of the future. And we have our barista here, Josh Cohen, who is operating a smart coffee machine. Now, this smart coffee machine is outfitted with several sensors that includes temperature sensors as well as weight sensors to understand the current state of the coffee setup. Additionally, we also have ambient sensors, which is measuring the temperature and the humidity of the environment. And lastly, we have an image sensor, a camera, that is focused on the tabletop. Now, the vision system using the camera is looking to detect and track how long coffee cups are on the coffee table and ensure that we understand how they degrade over time. So this example, while rather simplified, is indicative of what we see many restaurant operators pursuing, which is understanding how the physical environment is being observed and digitizing that information to understand deeper insights. As we saw from our barista, Josh, as he poured out coffees and went to serve our guests, we now can have a look at the digital data that's created from those physical observations. What we see here on the left-hand side is our vision system, and our vision system is detecting and tracking the cups as they are on the tabletop. And what you see is durations for each individual unique ID. On the right-hand side, we're looking at the sensor data, and that sensor data includes the ambient temperature and humidity, as well as sensors that are specifically on the smart coffee machine. Now, all of this is interesting if we're just looking at one restaurant, but where the insights really derive from is when you're looking at thousands of restaurants and you can start to uncover guest experiences or operational inefficiencies that are surfacing due to what's happening within the restaurant physical environment. So now we've seen a glimpse into the kitchen of the future enabled by Outposts. We are really excited to be able to run our AI workloads seamlessly in the cloud and at the edge to enable restaurant operators to create a better future.
I'm Dan Getman. I'm Vice President of Product at Capella Space. I'm super excited to be here at Amazon reInvent talking about the work that we're doing at Capella and the collaboration that we have with Amazon. For a long time, for decades, if you wanted a picture of the Earth from space, you had to be a large federal agency or an international entity. And all that's changed over the last decade. There are several companies, many companies that have started building and launching satellites and are collecting imagery of the Earth and selling that to the public. And that's a huge change in the space. There's a lot that we are able to do now that we weren't able to do before. But there's still many challenges with that imagery. Most of that is optical imagery, which is very similar to having a camera like the camera on your phone in space, taking pictures of the Earth. And so if it happens to be at night, you can't really get an image. If there happens to be a hurricane or weather conditions that would be blocking the surface of the Earth, you can't see through those. And also, the companies that are selling imagery in this way generally use manual process and method, and so there's a lot of emailing and phone calls and administrative work to get an image. And at Capella, we really wanted to turn that all around. And so we've created a constellation of radar satellites, synthetic aperture radar satellites, that allow us to capture imagery at night and also in all weather conditions. And so even in complete darkness, we can get a perfectly clear, high-resolution image of the Earth anywhere you want. We can capture images directly through an active hurricane, or in the case of this picture that's on the screen here, we can actually get an image of a volcano during a volcanic eruption. And in this case, we're looking right down the throat of the volcano. And it's not blocked by smoke and ash and things like that. Probably more important than that, though, from an innovation perspective, is the work that we're doing with Amazon to automate that. And so there are no phone calls, there are no emails. You can log into our system, you can zoom into a place on the Earth, you can select that location and say, I'd like an image, and everything else after that is automated. We use Amazon's ground station for downlinking the imagery. We use Amazon Cloud for all the compute, the image processing, the analytics, and we use S3 for the storage, which makes all of that incredibly easy to automate, which makes it very easy for our customers to leverage to get the imagery they need to make a difference in the world. So what I'd like to do is just demonstrate that and how our system works. This is our console application, which people use to interact with the constellation. We're looking at an image now. This is over St. Vincent, volcanic eruption. But let's go and get a new task. So we'll just zoom to Las Vegas, which is where we're at now, and go ahead and add a tasking request. So you can see the point on the map, basically as though you were doing something like searching for a restaurant. You pan, you zoom, you drop a point, and then you just say add tasking request down here at the bottom. We'll give that a name. And what's happening right now is we're running a process, automatically running a process on AWS to determine all the times, the opportunities for a collection that we would have over this location over the next 7 days. And so you can see that list here. If that looks good, if one of those times works for the image that you want to capture, you simply hit Create Task. And that's basically it. We'll hit Submit. It's essentially asking, are you sure, which this is the same kind of thing that happens when you order a pizza, right? Are you sure you would like that delivered? We're going to go ahead and say Submit New Task. And all of the rest of the process is automated. The communication with the satellites through ground station, the downlinking of the image, the processing of it into something that's valuable and useful, and the delivery of that right through S3 to our customers. So this is as easy as it can be made to task the constellation. And if you're interested in seeing more about this, we actually have an open data collection, which is available to go and browse and see beautiful examples of very high resolution SAR over some really interesting places and some vertical specific applications like infrastructure monitoring, sustainability, things like that.
reInvent 2021, a very warm welcome to you. My name is Shaban Saddique, Wipro AWS Business Group Director. Innovation in action is the cornerstone of our AWS and Wipro relationship. In our AWS Launchpad, we show the art of the possible by leveraging groundbreaking technologies. Robotics and AI is one such focus. In the COVID-19 new norm, we are seeing organizations exploring new ways to transform their work environments and leveraging robotics to basically do customer-facing tasks. Today, it gives me great pleasure to introduce Oslo, a humanoid who will demonstrate an April use case. And the whole objective and business value is keeping humans safe and keeping the industry wheels moving. Now, I'm going to show you an April use case when Oslo is going to assist a passenger.
Hi, welcome to McCarran International Airport, Las Vegas. May I know your name?
Shaban Saddique.
Please wait while I check your temperature. Please take a step back and look into the camera. Your body temperature looks okay. I don't see any deviation from normal temperature. Do you have your vaccination ID with you?
Yes.
Let me check your COVID status. Please take a step back and show the ID to the camera. I have verified your COVID vaccine status. You are good to go. Have a nice flight. How may I help you? Please choose from the following features.
Flight status.
Sure, please tell me your flight ID.
BA123.
The British Airways flight to London is on time and scheduled for 5:30 p.m. Can I assist you further?
Take me to the gate.
Sure, please follow me. I can also help you to carry your bag.
And there you have it, a customer-facing role performed by a robotic. To find out more, go to wipro.com. Thank you very much. Thanks for listening.
Hi, I'm Mike Tzamaloukas, General Manager of the AWS IoT Automotive team. And I'm here to announce a new AWS managed service called AWS IoT FleetWise, made for the automakers. The automakers are facing problems around collecting data from diverse fleets of vehicles, as well as collecting data from new sensors in these vehicles that generate high volume data, sensors like cameras, LiDARs, and radars. With this new service, we're looking to solve both of these problems. We're looking to make it easy and standardized to collect data across the entire fleet of vehicles for an automaker, and we're also looking to employ intelligent, dynamic filtering of the data in order to reduce and efficiently collect information from these high volume sensors in the vehicles. So we are looking forward to creating a new paradigm that will help the automakers create safer and more autonomous vehicles. If you would like to learn more, please visit us at www.aws.com/IoT Fleetwise. Thank you.
Hi, my name is Michael Mackenzie. I'm the GM for Industrial IoT and Edge at AWS.
Hi, I'm Saras Kaul. I'm a Principal Product Manager in AWS IoT.
So you might have seen in Adam's keynote that today we're launching AWS IoT Twin Maker. We're really excited about this one because it makes it really simple and really fast for developers to create their own digital twins. Tell us a little bit about the features, Saras.
Thanks, Mike. We spoke to a lot of customers. They told us they're collecting all this data for their operations and they want to use them to create digital twins. But there's 3 problems that they face. 1, the data that they're collecting lives in different places with no connection between them. 2, it's really difficult to model physical environments because they're so complex. And 3, it's difficult to create effective visualizations for end users so they can consume the data and insights to take actions. So we're really excited to announce Twin Maker in preview because it helps with those challenges. First, it offers data connectors to different data sources, including IoT data, process data, business application data, as well as video feeds. Second, it offers a flexible modeling capability that allows you to model the physical environment, all of its elements, and the relationships between them. And third, it provides 3D visualization capabilities so you can model your physical environment visually and also overlay and annotate that model with the data that has been modeled into your knowledge graph.
To learn more, go to aws.amazon.com/IoT Twin Maker.